Are you making fun of me? Who, me?
Yeah, you, Matt, oh, yeah. Oh, my God, I was laughing. Everyone was staring at me. They were all like, you get two over the guy, like, your dad, he was, we're like, talking about the limit, and then he was like, I get like, just like, screaming back, screaming. And I wasn't screaming, it was like a huge, I was like, really loud. No, it's my joke. It wasn't like, we weren't actually like fighting.
No, we weren't. And I don't ever get mad at you. You have to do something really bad, like, oops, shoot. Like, cheat or something like that for me to really get mad at you, which I know you will never do. So, okay, I got to go back to the beginning. Here we go. All right, here we go. You did do this last year. You did do this, okay? Okay. It was like chapter 7 or 8 toward the end of the year. So the first thing that you want to ask, ooh, lovely. So what you need to ask yourself is, what can't x equal? And where do we always look for that? Okay, so the other thing that you need to recognize is that everything needs to be written in factored form, not as a polynomial. Okay? So this one's going to be factored into x plus 4 and x minus 1. So basically, when we look at our denominators, we have an x plus 4 or an x minus 1 across the board, correct? That tells me then that I know that x cannot equal what values? 1 and negative 4. We keep this in the back of our head because when we go through solving, if we come up that x is going to equal one of those, we can't use it because we already said they're not possible solutions. Okay? So, first step that you have to do, and if you don't do it, I'll count it wrong. Not wrong, but I'll take off points. I want you to consistently get these right, and this has to be the first thing that you show me. Okay? The next thing that you're going to want to do is, ask yourself, do you like working with fractions? No. Let's get rid of it. All right? So figure out what your common denominator is. And once you know what it is, then you multiply through by those factors. So what is your common denominator for this? Okay, keep it in factored form. X plus 4 and? All right, so look. If I multiply x plus 4 and x minus 1, and I take it to this first term, what happens? And so then I'm going to take my x and multiply it by what? X minus 1, right? Because if the x plus 4's drop out, then I'm left with an x minus 1, right? If these drop out, then I've got the x times the x minus 1 for the first term. Remember this now? Well, I'm not done yet. Just. This is not working. Okay, here we go. So now we take it to the next term. And this needs to be highlighted. You will consistently forget that stinking negative sign. And that's why I put it on this problem. This is a negative. What is going to drop out in my next term? So that means I'm going to take this 2, which was my numerator, right? And multiply it by what? All right, and equals, when I take it to the last term, what is it going to equal? So pretty. We can solve this, right? We can solve this. So I'm going to get x squared minus x. Okay, what am I going to get? Minus 8. Invariably, somebody forgets to take that negative 2 to that last term. That equals 20. That means to solve, we have a quadratic. We have x squared minus 3x minus 28 equals 0. Yes? We can factor, use the quadratic formula. We get x minus 7x plus 4 equals 0. What are my possible value or my solutions? And where do we look We go back to here and make sure that none of our answers were eliminated as our very first step. What was eliminated? That means our only solution is 7. Yes? Mm-hmm.
So,
Mm-hmm. Okay.
okay. Oh.
Mm-hmm.
If you like couldn't factor it out, if you just do like
I do quadratic. Don't use completing the square unless I really ask you to. It does. It just takes a little longer. Quadratic is much simpler. Okay. So next one. Is this better now? You understanding this? All right. First thing you're going to do is put that a over 1. A squared minus 5. I can't factor that. Can I factor this denominator here? What is it? Yeah, you've got to start recognizing the difference of perfect squares. Can I factor the numerator of my next one? I did. So what is my common denominator? What can't x not equal? -1 and +1, right? So those are the first things we want to determine, correct? So now we're going to take this denominator that's common, which is a plus 1 times a minus 1, and distribute it to every term. Well, what happens when I go to that first term? Anything drop out? So I'm going to have an a times an a plus 1 and an a minus 1. So then I go to my next term. What drops out? Both, right? Don't they all drop out? And so my next term is just going to consist of that a squared minus 5. Would you agree? Because everything, all of these terms are going to get canceled by what you're multiplying. Okay, and then when I go to my next term, I'm going to take that a squared plus a plus 2, and what do I multiply it by? A minus 1. Okay, Megan? Okay. Now, it's simplest here if we take a, and we know that a plus 1 times a minus 1 is a squared minus 1, which then gives me a cubed minus a. All I did was do that first little portion. Okay, this is going to stay, and it's positive, so I don't have to worry about pulling out a negative, right, or pulling it through. This is going to stay a squared minus 5. And this is going to be a cubed minus a squared plus a squared plus 2a minus 2. Would you agree? So my whole equation starts by saying a cubed minus a plus a squared minus 5 equals a cubed plus 2a minus 2, because the a squareds drop out on the right side. Oh, thank you. So, plus, thank you. Allie, are you copying all this down? You look like you're in La La Land.
wait, why is it plus a?
I forgot to distribute the a times a -1. It's a cubed minus a squared minus a, 2a minus 2. I just dropped a term. So, okay, what's going to drop out? Don't the a cubes drop out if I take them onto the same side? So order everything. A squared minus 2a minus. No, because one's positive and one's negative. They have to be the same sign for them to drop out. And so this factors to a minus 3 and a plus 1, which leaves me with a equaling 3 and are those okay? Which one doesn't work? So that means a equals 3 is your solution. Okay? No. Not happening. build your ability to think rationally and show all your work. You know what? Here's how I think of math. Working math problems is like writing an essay in English. You can't just go from the start to the end with nothing in between, right? You've got a process to show. So you are writing mathematical essays.
That's all I know.
Whatever.
That's bad. That's fabulous.
We're going to do decomposing now.
We're not going to do you try?
No. We're, good. If we have time, yes. You got to catch up.
We're going to have a lot of time.
We'll see. Do I see you tomorrow?
Yes.
Yeah, I'll shorten it. I will. Shh. Here we go. Decomposing. So the whole idea of decomposing is we're taking this answer and we want to figure out what were the two fractions that we had to begin with. Yes, you did. Okay? So the first thing that you need to do is factor your denominator. So this denominator factors to 2x and x minus 5 and plus 1. You can use your box method. You're going to have to factor. You have to start becoming very quick when factoring because I learned a trial and error, and because I've done it so much, I can see the patterns. I just knew if I need negative 9, I need to get negative 10 and a positive 1. The only way I can get negative 10 is if the first and the last give me the largest value. So, okay. Express the sum of two fractions using a and b as the numerators and the factors as the denominators. So basically, I'm going to say that negative 2x minus 23 over 2x squared minus 9x minus 5 is going to equal a over, pick a factor, 2x plus 1, plus b over x minus 5. I don't really care which one has the a and which one has the b. It really doesn't matter, okay? I'm simply trying to figure out what my numerators are. Now, I do this a little bit differently than the book does. So you can go to the book and go follow their method. I'm going to do it using systems of equations. Okay? The next step that we are going to do is we're going to eliminate the denominator. Well, how do we eliminate the denominator? By what? Which is what? Right, so when we eliminate the denominator, so we multiply all of this by 2x plus 1 and x minus 5, what we are left with is really kind of the numerator on the left side, yes? We're left with negative 2x minus 23, and then we get a times what? And b times 2x plus 1. And then we're going to distribute, okay? We're going to get over here ax minus 5a, correct? And 2bx plus b is equal to negative 2x minus 23. All I did was distribute. You really got to pay attention to what I'm doing here, okay? A times x and a times negative 5. Okay, now we're going to get our x's together on the right sides and the terms without x's together. So I'm just going to say that this is the same thing as saying ax plus 2bx, correct? And negative 5a plus b. All I did was just rearrange the right side. Got my x's together and my y's, or my nothings. So then I'm also going to say here that this is the same thing as x times a plus 2b. Would you agree? All I did was pull out my x. Yes. notice that this term has an x in it and this term has an x? That's going to tell me that negative 2 is equal to a plus 2b. It has to. The one with the x has to be, they have to be the same. Because I pulled it out. This is something times x. This is something times x. Therefore, they have to be the same if the left side has to equal the right. I'm not. I'm saying they both have an x. So whatever. So let's say that this is 5. 5 times x. This has to be 5 times x, which would make, okay. What is my next equation going to be? Right? This has no variable on it. This set has no variables on it either, right? Do you see we have 2 equations and 2 unknowns? What are we going to use? Use your matrices.
Oh my.
Use your matrices. That means my matrix is going to be 1, 2, negative 5, 1. This is my A and my B, and that's going to equal negative 2, negative 23. Sure, you can. Go for it. Got to do the inverse. Uh-huh. This has an x, right? This term has an x. Therefore, those 2 terms have to be equal to each other. That's all I wrote. And therefore, this one that has no variables has to equal the rest of this that has no variable. Okay? All right, so then what do we get? What do you get? I got like a negative 11 fourths and 7 halves. Then my work's wrong. Okay. So A is 4 and B is? So basically, if I go back up to this, A is 4 and B is negative 3, right? Did you say negative or positive? So these are my 2 equations then, or my 2 fractions. So 4 over x plus 21 minus 3 over x minus 5 is going to give me this mass if I were to go back through the process of getting a common denominator. Right. All right, here we go. We're going to do another one of these, okay? Yeah, I just want to know. So you're going to need to tell me that it's 4 over, what did I say? Plus negative 3 over. Yeah, because, see, I don't know where your A is. I don't know, is your A over 2x plus 1, or was your A defined to be over, yes. Mm-hmm. I don't know. Should be, yeah. Should be. Oh, you know what? No, I'm sorry. It's, how about now? Huh? Yeah? See, I have inverse up here. So I go, do you have it in the same order? 1, 2, negative 5, 1, negative 2, negative 23. Right. All right, let's try the next one. Where is it? Is that it? Let me clear it up. Okay. Okay, so the first thing we want to do is factor. So this is x minus 7 and x plus, no, that's not. X minus 5 and, so that's a over x minus 5 and b over x plus 2. Remember, it doesn't matter where your a or your b is, which is why you have to write your answers over your denominators. Okay, so when we multiply by the common denominator, I'm just going to go CD because we're running out of time. That leaves me with x minus 2 is equal to a times x plus 2, and b times, and then what do I do next? Not yet. ax plus 2a plus bx minus 5b. And now what do I do? Okay, so that's 6x minus 2. So that's ax plus bx plus 2a minus 5b. What do I do now? Pull out the x, a plus b, and 2a minus 5b, correct? So now let's jump right to this. This is going to be a 1, 1, 2, negative 5, won't it? 1, 1, 2, negative 5. This is going to be what? And negative 2. Right. Get the order right. Yes, thank you. I dropped my negative 1. Board 2. Okay, I'm going to have you do 13 through 25, the odds. What did I say, 13 through?
25 odds.
Okay, they're in the back. And we'll just do a little bit more on 4.5 tomorrow, 6 tomorrow, and 4.7. Anybody not get this one to work? Yes.